My name is Chuck Hudson. I'm in Comcast Corporate. I oversee our global security strategy and technology innovation. So if we could start by you guys introducing yourself, and since we're late, if you do it really slow, we'll probably be done afterwards.
My name is Joseph Feiman. I'm from a company called Veracode. I am Chief Innovation Officer of Veracode, company that does application security testing.
Hi, I'm Vinod Vasudevan from Paladion. So we are a platform-driven security services company, and so we deliver DevOps security. We do managed services, next-gen SOC, and consulting.
Good morning. My name is Jon Ramsey. I'm the Chief Technology Officer with SecureWorks.
Good morning. Stephen Grossman, VP of Strategy and Enablement at Bay Dynamics. We're a cyber risk analytics company. Helps you prioritize and respond to your top risks.
Great, thank you. I think I'm going to start by just giving you a couple stats about DevOps and then open it up to get your thoughts on it. And when I was doing some research and reading this, I came across multiple different numbers, but ones that really impressed me were that Gartner predicts by the end of 2016, 74% of companies will be using some form of DevOps, which is an amazing if you look over the last 3 years. But what was even more interesting is if you look at it from an enterprise versus a small and medium business perspective, and almost 90% of enterprises are using some form of DevOps. And so, of course, if you haven't figured it out yet, I was a math major. I like numbers. So then I took a look at it and said, well, where is DevOps really in the corporate environment? So you would think if 90% of companies are using DevOps, it'd be large corporate programs. Actually, it's not. 29% of DevOps is actually run within individual teams within the corporation. And 31% is run within specific BUs within the corporation. And only about 20% of corporations actually have a standard corporate DevOps model. So it literally is run, from the grassroots up. So I just wanted to get some of your opinions of what you're seeing in the market and where you see DevOps today.
What we're seeing in general is an evolution, like you're saying, where it's coming up from the grassroots, and it's really focusing on the highest value applications, where they want to get it right, so to speak, in the new infrastructure. It's a little bit hard to apply to old infrastructure and to old applications. And it's that evolutionary process that as the methodology gets refined and as people start working together, that whole shift left mentality starts to pervade the organization.
Yeah, for me, businesses are driven by time to value, which is when they have an idea to when there's revenue on the P&L. And DevOps is being looked at as a way to shrink that time. Fundamentally, time is not on the developer side. I studied software engineering at Carnegie Mellon University, and you can mathematically prove the completeness of a program. What DevOps, the promise of DevOps is to shrink the cycle, the time to value cycle, and give the developers the ability to release things quicker in a more agile environment. And it tends to be new applications, not legacy-based applications, and new revenue-driving applications where we tend to see that the most.
Yeah, so I think what we have seen is for the larger enterprises, of course, the speed to market, wherever that is required, that is getting to DevOps. The rest of the applications, usually it's a kind of hybrid. There are certain things within the DevOps which gets waterfalled, but then the rest of the operations are still DevOps. But there is, on the mid-size segment, possibly, there are a lot of companies who are into that startup mode, and the web-enabled companies, I think they are going into DevOps from very early cycles, leveraging the cloud to the operation.
Thank you. Let me turn this a bit. We know more or less what DevOps is, and it is reasonably mature. But I believe our panel today is not about DevOps. It's actually about securing DevOps, or DevSecOps. And there, I can tell you exactly where DevOps is residing. I've been with Veracode for 10 months. Before that, I was a Gartner Fellow, lead analyst in application security. And every year, my responsibility was to build so-called hype cycle, the Gartner map that positions maturity of different application security technologies. And every year, there was one problem with one market or concept called DevSecOps, and we never knew where to place it. We barely moved it from year to year. And it's currently sitting with a status trough of disillusionment. The previous one is peak of inflated expectations, and DevSecOps has passed it already, thanks God. Now it's in trough of disillusionment. So this is the problem that we should be dealing with.
And to that point, by the way, you stole my thunder. If we talk about DevOps, and we talk about SecOps, and we talk about DevSecOps, really where is the market today? And another stat I wanted to put out there around that is everyone knows of Chef and Puppet, but only 40% of corporations are using some type of product like that to control the configurations that they're using. So if you look at the market today and the products that are in the market and their usability in the DevOps model, where do you really see is trending? Do you want to mix it up and start?
Okay. Because I was dealing with moving that DevSecOps year after year and finally got to that trough of disillusionment, I was asking myself why it's behaving so poorly. Look at other technology, tokenization. In 3 years, it moved from inception through trough of disillusionment, immediately in enlightenment, and it's fully mature technology, just in 3 years. DevSecOps is not moving at all. So I very sincerely try to figure out what DevSecOps means. So I start reading different documents and listening to people. And you know what I learn about DevSecOps? That it's all about principles and methods and methodologies and culture and blueprints. I have much longer list. I cannot remember it. I've not invented it. I simply copied it from one of the Gartner white papers. That's all that we say about DevSecOps. Culture, culture, and culture. And when I look at this long list of recipes and blueprints and cultures again, I'm asking myself, it sounds, it looks really odd. There is something really strange. A critical piece is missing. And that critical piece is a technology. There is no technology in DevSecOps. Look, how come that there is no associated technology to the market? Look at other markets. Web application firewalls, they have firewalls. Network firewalls, they have firewalls. SIEM technologies mentioned today, they have their repositories and data feeders. Look at tokenization, they have their servers, and only DevSecOps have no technology. Isn't it strange that there is no dedicated technology associated with DevSecOps? That was my first concern. And sometimes I hear, well, all technologies, just all security technology will be able to adjust into DevSecOps. And that raises my concern. I sincerely don't believe it. So we need to find the technology and define this technology that will really fit into DevOps, making it DevSecOps.
So I think when we look at how to really make, so it's all about how do you infuse security into the DevOps operations. And I think the last session from Nupur, there were a lot of insights. So I strongly believe that if you define success criteria around what can really infuse security into DevOps, I would say that one, the security models now have to work at the speed of DevOps. That's very critical. And for it to really work at the speed of DevOps, all these security processes that we are talking about have to work in that continuous and incremental model. So if you take an example of threat modeling, if you look at the waterfall method that we were using, it was typically a cycle starting from your software requirements right up to the testing and deployment stage. where it went through different stages. It could be, it was months or, years in some cases. So the threat modeling as a concept there was, a very comprehensive exercise that we would do at the beginning of it. After that, the whole focus was traceability. This threat model, is it seen in design? Is it seen in testing? Is it seen in coding? But if you just take the same process today and try to apply it to a DevOps model, that's bound to fail, because it's not really about the comprehensive nature of threat modeling, but it is more about, is that process infused into the DevOps cycle? Is it incremental enough? Is it getting into, say, a grooming stage, a discussion on a product requirement when it is happening? Is somebody really coming in and discussing the security, the threat model aspect of it? So it's more about how do you break it down. The second piece, which like what Dr. Joseph Feiman said, if you take the technology, so you need to really integrate a lot of technologies into the DevOps cycle. So you need the code, the code scanners, you have the dynamic testing tools. When it comes into operations, you need the security monitoring to kick off once you put it into production. So the reality check is many of the tools that we have today don't really blend into that DevOps mode. I mean, try putting an SIEM tool that we have today into a DevOps cycle in Amazon, and you would know what it means to make it operational. So I agree that there is a need for a security automation layer, which I think in the market or built by the organization, which can kind of abstract out the integration issues with the current tools. But for the DevOps itself, it has to be like an easy integration option that is available, right? The final point and most important, I think, is for success, it has to be seamless for the developer. So the developer has to see everything in his environment. So if you take the case of threat profile itself, the developer has to see it possibly as a security user story for him to get it implemented. Or if you're talking about a K-base that helps him fix certain security issues that are detected, it has to be available for him in his defect tracking tool. So the more you try to infuse and make it available in the developer environment and make it seamless for the developer, I think the adoption will increase. So that's something that we are getting to see.
I want to talk a little bit on the production side of DevSecOps that I think is interesting to consider, which is developers are always going to inject vulnerabilities. It's just the nature of the space we operate in. I would guess that less than half of people who write production code actually have computer science degrees today. So where the promise for DevSecOps there is, all right, and vulnerabilities get injected, they get discovered, disclosed, and then attacked. Somewhere after they get injected into the code and into production, they need to be fixed. If you look at the attacks that we monitor across our client base, in open source software, from the time the vulnerability is discovered to the time it's disclosed, it's 8.3 days. In closed source software, the time it's discovered to the time it's disclosed is 56.3 days, so there's a big gap there. So you see a very vibrant community looking for vulnerabilities and disclosing them. Now the inverse of that is true from when it's disclosed to when it's attacked. And so it's from 8.3 days from discovery to disclosure for open source, and then 108 days to it being attacked in production. And on the closed source side, 56.3 days discovered to disclosed, and then 84.3 days. It's a shorter life cycle. The thing that we can do with automation of systems administration is get out of this vicious patch cycle. And now, instead of actually patching machines, we just, to use the cow analogy, take them out back and shoot them, we shut them down, and we redeploy a new image. And now we can get in front of this cycle post-vulnerability injection.
So I think you have a combination of a few factors. I mean, change is hard in all areas, right? Cultural change is hard. The cultural change of getting developers to change the way they do things, which is why programs like this are so phenomenal of building it into the curriculum, like the discussion we were having before. Essentially, to make that culture change happen, it's a continuous improvement process. Right? You need to be able to connect the dots between the bugs that are coming out of the code, the bugs that are the security vulnerabilities in the code that are being maybe exposed in static analysis to what's actually being seen in the wild, to what's actually being seen in your applications, and bringing those together so that you could obviously patch them in a much shorter time frame than what you're speaking of, but in addition to that, feeding that loop back into the development community so that they understand how to improve what they're doing. Right? It's about bringing that data together. It's about being able to get the right metrics and the right communication to enable that black box thinking that Newport was speaking about just earlier this morning, and really bridging the gap between development, security, and operations as one team.
So I get asked the question all the time, how are you able to find and detect all these new vulnerabilities and stay up with what's going on? But what I found very amazing, and I actually got this off of the Veracode website, it's probably no surprise to this audience, that 50% of the application vulnerabilities out there today are cross-site scripting and SQL injection, which has been around for 15 plus years. So we've gone through all these different types of development models. We've gotten better and better in technology and how we discover these things, but we seem to come back to the very fundamental issues of coding. So, I would be curious to hear, because I know we have a lot of people here that are from very large testing companies, what do we really do to change the culture and change the paradigm from a development perspective?
I mean, I think part of it is time and pressure, right? I mean, in large corporations, the developers are under tremendous pressure to produce and to get their changes out into the wild. The same kind of statistic around vulnerabilities. Most of the vulnerabilities that are exploited have been around in the wild for more than a year, right? So a lot of that is because people can't prioritize what they're looking at, and people really are focusing on the wrong things, I think.
Yeah. So I think it's a great observation that we get to see. So in most of the places where we do the application security programs, the statistics are the same. The top two would be essentially SQL injection, cross-site scripting, and maybe parameter manipulation would come in as a third. So I think the key reason why we possibly get to see it is, in spite of, like you said, 10, 15 years. Okay, one of the key issue would be like the movement that is happening now in terms of trying to shift this application security as much as to the left as possible. I think that would help, which is still not done in most organizations. So I think the technology is also evolving there. For example, today you have those spell check kind of options within the development environments where as you code, of course it's not so mature, but I think it's getting there. So you get to see what is happening. Developer immediately gets to correct the code as he is kind of keying in. Awareness programs will, of course, play a big role. But I think we also have to realize that while we just say cross-site and SQL injection at a very top level, there are n number of variants that have evolved over the years, depending on both sides. The technologies are also changing dynamically. So the SQL injection, the variant of SQL injection on a technology is definitely different. So the top level looks same. The second aspect is, of course, the attackers are also finding out the same variant. And these are two that can lead to the highest impact. So obviously, there's a lot of research on the attacker side to find new ways or variants that can do that. So that's, I think, while the top level looks like SQL injection cross-site, I think the key factors move more to the left will solve. Of course, that's the initiative by mature organizations. Second is we have to recognize that technology changes it. Therefore, a lot of variation around it is happening. And the attackers are just leveraging that. So that's I think, is what is happening.
Thank you. I believe, speaking of culture, that we're making a mistake when we expect that our developers will ever become security specialists. They will never become security specialists, so we have to find something else. As an analyst in Gartner just 10 months ago, I was taking 500 inquiries every year for many years as a lead application security analyst, and a very frequent question was, Joseph, I'll take just 1 minute. I know the answer, I just need to get access to best security programming practices, and when I teach my developers these best practices, they will program securely. the most naive and very frequently asked question. That is practically impossible. There are a number of reasons why developer people cannot become security specialists. One of them, sorry to say that, mentality. When they develop an application, what they're trying to do, they're trying to prove that application does what it's supposed to do, right? But this is not what security testing should be. Security testing is not to prove that application does what it's supposed to do. Security testing is to prove that there are ways to force or trick application into doing something completely unexpected, called exploit. Then, security is never a priority for developers. They're driven by very different set of objectives. They need to deliver functionality, not even quality, but functionality right in time and under the budget limit. They simply have no skills, no aptitude, no desire, no objectives to do security. Security and overkill. Therefore, we have to come up with a smart approach. What we've been doing since about 2005, when first tools have emerged, we started buying security tools and giving them to our developers, but they have no time, efforts, aptitude to run, to learn these tools, install, maintain, run, and be responsible for results. Simply no time. That's why the second paradigm, delivery model, has emerged, security as a service. Service coming from the model, completely invisible to developers. So the great idea of embedding SEC into DevOps is that SEC you should never learn, never run, and never see. Of course, you have to get some training. You have to understand what SQL injection is, but you cannot be enforced to do it. Security should be completely transparent in terms that you really don't see, don't run, no invoke, don't learn. It should be like electricity. That's my analogy between SEC in DevOps SEC with electricity. In order to light that room, you turn the switch and it gets lighted. But you don't see electrons, you don't learn electrons, and you actually don't push electrons to run. That's what SEC should be for DevOps. Therefore, one of the great steps forward would be not buying and giving security testing tools in particular to your developers. They'll never be proficient. By the way, who will enforce them, and will they admit that they made these stupid mistakes, foolish mistakes, sorry, while they develop insecure applications? Security should be coming invisibly from the cloud, delivered by third-party independent vendors. And that's just one thing that should be done along other things.
Right. So I'm going to add my theory to it, and I think it has a lot to do with reusable code and continue to use bad code over and over again. So this is my last question, so I need the grand finale, fireworks and all. So what is your take with DevOps and using either public code, third-party code, and really meshing together all that in the speed of light to develop and produce an app that's quote-unquote secure and able to go live?
Well, in 2008, we defined a market called SCA, the Software Composition Analysis, and that's the technology that enables you to analyze third-party code, specifically open source components. It should be a mandatory technology. When I defined that market in 2008, I gave it importance of moderate. I believe that next year Gartner should actually raise importance to high, because it's become very clear that software composition analysis is actually supply chain analysis or supply chain assurance technology that is a must for all our organizations, simply because more and more we compose our code out of third-party components. So I would make it mandatory.
Yeah, I think software industry also would definitely move the way most other industries like manufacturing, etc., has moved. So you try to get components that you can put together, right? So if you look at software development today, it is definitely a combination of pure development as well as assembling of already available components, right? So it's like the pipeline. So you would obviously use a lot of open source components which are available, and also commercial components, and more we get into the the dynamic nature of software and the cloud and all the things coming together. So it's going to be a lot of REST APIs talking to each other. It's going to be a lot of ready-made components that you can use, including open source. I think that's where the world is moving towards. So to that extent, having the capability to analyze an open source when you are integrating that definitely becomes a critical part of the overall, it's not just open source. You might tomorrow, just buy a certain capability as a software as a service that's going to become very common. How do you really then determine how safe is that service that you're, trying to integrate with? So those test components will become critical as we go.
I think the best thing we can do from a security perspective for DevOps is to protect the developers from themselves. And I think the idea of having a API interrogatable policy framework that gives something to the developer that they know how to consume, interrogate, and ask questions and make decisions based on that, what's risky, what's not, I think is really an intriguing idea. I think there's something in there for securing DevOps.
And I would flip the question around a little bit, because I think bad code is bad code, right? I think if you flipped it around and you used reusable code and you use that modularity to improve your security, to improve the way your coders are working, so that you're certifying and validating that reusable code that you're, whether it's open source or whether it's closed source, you can make that really a competitive advantage to be able to increase the quality of your code. And it comes back, going back to one of the comments Dr. Feiman mentioned earlier, just about the culture. I mean, I totally agree that I think you need security to be easy, right? It has to be the easy path for developers. But as a cultural component, I think you could very much educate developers if you make it part of their metrics and part of their objectives. You'd never accept low-quality code from a developer. You're monitoring the quality of the code from your developer. You always want to monitor the security of your code in just the same way, as was mentioned earlier this morning about making security just another measure of quality.
Good. Another comment?
I just want to add one thing. I believe there are three types of code, so to say, that we have to be aware of. One is the open source code, and we have software composition analysis that takes care of detecting malicious or illegal components. That's number one. That's a must. That should be done. The second one is testing components that compose packages that we buy from commercial vendors. If I have like 30 seconds, I'll tell one of the most amazing story that I got listening to the client several years ago. It happened also in university, in one of the universities in the United States. They acquired a system for, I believe, student enrollment, and it was a great system. It worked. Suddenly, the governor of the state issued an order going back saying that every package acquired by the university that belongs to the state should be tested. They run the test. They detected about 300 SQL injections only. So she called me, and she signed under that. She called me and asking what could be done. And I tried everything. And she was saying, no, and said, finally, you're actually looking for a magic? And she started crying. She said, yes, I'm looking for a magic because I went to the vendor and I told him that there was 300 SQL injections. And he said, we are not selling security. We're selling functionality. Are you happy with functionality? Goodbye. That's the story. So the second thing, we have to have technology that would test packages from commercial vendors. And the third thing is, it's not exactly code, but do we know how many unused applications, web applications we have? Our company research shows that about enterprises underestimated by like 30 to 40%. There are 30 to 40% more websites that belong to you and you are not aware of it, but they're still there, still running and cause as an entry. So we need to have some kind of a application perimeter monitoring technology to take care of that code and application running and causing problems. Thank you.
I think we have time for maybe one or two questions. Lauren, did you want to ask a question? Go ahead.
So I want to go back to something, Dr. Feiman, you said about developers will always have, they will never be security professionals. You mentioned about developers never being, security minded and developing secure code. The challenge is we just don't have enough security professionals in the market, whether it's in our enterprises or as a service that we could get from other vendors. So I think the challenge is upon us to bringing them into the loop and making security not as another added layer of headache that they have to deal with, but as part of their delivery, thinking of the functionality that's expected and the culture that supports it. And I do get it, that it has to be kind of set the tone at the leadership level so that it could be understood that developing a secure code is actually rewarded. So I want to get your thoughts on that.
You have to train your developers. You have to actually train in security all your employees of your IT. So the security awareness should be part of your training. Some of them should be trained better than others, but overall, you cannot expect that they will be addressing, when they're programming, they will be addressing all hundreds of different best security programming practices for different programming languages. Moreover, you would not have resources to enforce this implementation of best security programming practices. And code reviews, these manual code reviews, are completely insufficient. One poorly knowing security specialist reviewing code of another one poorly securing no code specialist. So they do have to have security awareness training. Some of them have to have better training, but DevOps offers you an opportunity. A single file, a single Java class written. It goes, when you save it, it gets compiled in 3 seconds. In the very same 3 seconds, it's get tested by security testing technology. That developer gets results back, sees it immediately. By the way, that result is not being shared with team manager and peers, so whatever mistakes in security part you made, they're invisible. You fix them, 3 seconds, you get results back. Technologies exist, they're evolving now, they exist. You mentioned one of them, calling them spell checker. Well, not the very best name we know, but we'll find one. What is very important about this approach, you can test file by file, every single tiny file of 3, 5, 10, 20 lines. And the very important moral thing, it's not an embarrassment anymore in secure development. It's a word, because you received your results, nobody see it, you fix them, you send for another test, it's fixed. Now you deposit it to repository, and now you continue to the next step, to the team view, when your entire team sees these results of reasonably well tested for security vulnerabilities. It continues working on that, and then it pushes to the next step when your quote-unquote traditional static analysis runs for several hours and looks out for remaining security vulnerabilities. So you're scaling from extreme speed of development to complete coverage, and you cover them completely. And developers in that case, they are focusing on what they're supposed to do, developing business logic. Security of the code is being continuously, really continuously, file by file, snippet of the code, build by build, to complete application. It's being tested automatically, desirably from the cloud, making security tools completely invisible.
My question here is continuing with the previous question. Is that the delivery is the primary motive? Can we put some responsibility to, biggest software developers to the smallest one? So something like within a month of your release, if there are certain number of vulnerabilities are found, there will be that much of penalty. I think this is the only industry who doesn't have any responsibility. If you go to the engineering, there is a PE certification. If you go to medicine, there is a certification by doctors for their quality every now and then. So I think unless it is taking some responsibility, things are not going to go away. It seems that there are more hackers than the security professionals.
Yeah, let me add one comment to that, and then one comment to that. Look, I agree that the vendors should be held responsible for the security of their code, but you as a market should also be held responsible. If I give you 10 features at $1 and one feature at $10, what do you buy? You buy 10 features at $1. So the market is not incented. You're not driving, incenting in vendors to build secure code.
Delivery should be functionality plus security.
Yeah, sure, but the cost to deliver, and this is where DevSecOps helps, but the cost to deliver a secure feature is more expensive. And if the market is willing to pay for a more secure system, then pay for it, and vendors will produce it. I think it's a give and take, not just on the vendors, but also on the market. One other comment quickly about how many of you have written a piece of code? So when you look at the code and you go, it should work, and it works to my specification, but for some reason, when I run it in the system, it doesn't work. What do? You turn all of the security features off. You're like, oh, maybe it's an authentication problem. Maybe it's an authorization problem, right? Or maybe it's a performance. You turn all the security features off. And then you go, oh, wait a minute. Now it's working, so there's security is a problem. But the point there is a developer, similar question, you're not incented to develop something securely. You're incented to develop the feature. And the problem is a systemic problem, not necessarily a component problem. You can test on the component feature basis. You can even to some degree test on the systemic basis. But things like logic flaws and things like just turning off authentication because we want the feature to work is something that is really hard to test for.
So I think just to add on to that question, I think it's the accountability for the software industry in terms of bugs, etc. I think we are not too far away because if you look at the IoT space, if you have as many flaws getting into software within the IoT space, tomorrow people can lose their lives, right? So from that perspective, I think the accountability will come in much faster than because of this whole IoT explosion that's happening, because that leads to safety issues, and therefore the regulatory things will have to kick in, right? So accountability will start. Like you said, you can't say that I create cars with bad brakes, not acceptable, right? So same thing I think will happen. But in terms of integrating, I think the other question about developer and security specialists, developers might never be security specialists. That's too much to ask for. But the more seamlessly we can integrate security, like what Dr. Joseph Feiman also said, the more adoption will happen. Which means that for a developer, he is just churning code in the background. When he is doing the build, the scanners kick in, they do the tests. And then the bug tracking system, he gets to see the security bugs as well as possibly a K-base to fix it. So the developer is working as he normally works, but then into that cycle, he can get very seamlessly get to see security issues, what are the solutions, and within his environment. The more we have of that, and the more we move into the left side of it through more awareness programs, etc., I think we will have developers who are aware, and we will have security built into the software. They need not still be specialists. Of course, you will still have specialist intervention as required. The other practice that we are also seeing in some of the larger, really critical security development is, can I use some more analytics on the kind of output that we are seeing? For example, when you have a large development, a lot of development teams, a lot of products that are getting developed, can we have, and you're getting to see all kinds of code and the fixing that's happening on a continuous basis. So can we have analytics that says, my mean time to remediate, say, SQL injection is highest with a certain team, right, or a certain set of developers. So therefore, can I focus training on these aspects of SQL injection more on that development team, right? So it's a more rationalized effort that can come in by applying those kind of analytics and metrics on top of the output that is coming in. And once that is also built into the quality process, then automatically as a culture, the developers will be held accountable, because now you will have a metric that says that, this particular product team generated so many SQL injection on an average this month, and it took so much time to fix it, right? So it becomes a quality metric and it becomes a performance measure for the organization. So those are ways that we see that enforcement is happening. And that will only work the more seamless you make it for the developers, because otherwise you're creating a friction where you're adding more onto them, but then you're also holding them performance accountable. But the more seamless it is, it's a more balanced approach.
So I think we have time for one more quick
Chuck-
question.
Chuck, I was just going to just add to that real quick if I could. And, I think I would compare that a little bit to what we see with non-malicious insider threats. I was on a panel a couple weeks ago in Washington at the Billington conference with some gentlemen from the CIA and NSA. We were talking about non-malicious insider threats. Users, every company has a big problem. People just doing their jobs, sending out emails with sensitive information or violating policy otherwise. And somebody in the Q&A session got up in the back and said, "Why don't you just fire him?" Right, and the reaction, obviously, everybody was kind of laughing, but I think to Vinod's point earlier, I think if you make the measurement and the metrics clear and you build it into the culture, and you're able to put that continuous improvement cycle back, so that you're training your developers and making it part of their part of their measurement and part of their compensation and part of how they do their job every day of the week, and provide that targeted training so that they know what they're doing wrong when you start seeing it in the wild and when you start seeing it on the platforms. I think that cycle, together with the automation, will bring it home.
Hi, can I ask your opinion of IAST and RASP, and especially RASP in terms of use in production and impact on production as part of the technology solution?
Well, it is an evolving technology. Gartner gave it a transformational status. The status typically goes from low to moderate to high and stops there. Very seldom technology is given transformational status. RASP received that transformational status. But it's still a very early technology. Huge capabilities, yes. It's very early. I defined it in 2012, and I gave it 10 years to mature. So my expectation that it will mature around 2022. So we're about 6 years from maturing of this technology. The capabilities are quite amazing. It is a first time give cell protection capability to an application, and without changing any application's code. It's an standard instrumentation of a runtime environment, such as your Java virtual machine, or your .NET CLR, or your Tomcat or Jetty server, or whatever. That becomes an integral part of runtime engine. Therefore, it sees the entire data stream and logic stream. It can distinguish benign access from an attack. It can see database being open, data retrieved, data processed. So it has the most complete information about the potential attack, and it can stop attacks simply by not executing next supposedly malicious attack. Technologies, they start evolving now. Veracode, for example, has this program as well. It is immature overall with a huge potential. When it matures, and it will take some years, it will be perfect fit into DevOps, because you really don't see this technology, you don't run this technology, and you don't learn this technology. There is nothing to learn. It's a part of your JVM. There is nothing to see. You don't see as a developer your virtual machine running. And you don't submit requests. It's always running, always providing requests. The accuracy is supposed to be the highest. And unlike existing technologies that we use today for application protection, I mean web application firewalls, that don't have insight into application, this one does. Have I answered your question?
Yeah, I'd also like to know specifically in terms of performance issues and ability to cause system crash.
there are several, even the greatest technology must have its weaknesses. I can list some of them. One weakness one challenge of this technology is language dependence, which means that you have to have REST for Java, and another REST for .NET, and another REST for PHP. Is it a problem? It is, but industry has already solved the problem because emerging vendors have already built REST for major programming languages. Another one is performance. This is the least important thing that I believe that REST will encounter. There is one direct way to deal with performance. Place your application, that runtime instrumented agent, on a more powerful server, and a year from now, Moore's Law will take care of it. That's one solution. But another one, we've learned for 40 years to tune up our runtime systems. This is just another runtime system with instrumentation. You are not, when you're running your Java virtual machine, are you asking question how much time, how poorly performing your garbage collector? No, you simply don't know it exists there, but it does. That's another feature capable of detecting vulnerabilities. So we've accumulated for decades of IT experience ability to tune up the system. So that performance will be solved. The third one, when you spoke of crashes, this is actually an issue of a novelty of a technology, and that's the most serious issue. We get used for the last 15 years to web application firewalls, and we buy them and spend more and more every year, at the same time perfectly understanding that they are not protecting our systems well. But we know them. REST protects our system, but it's new. So we need to just accommodate to the novelty of this transformational technology.
All right, so with that, I wanted to thank our esteemed panel.